And in our today's class, we have decided to look at a question in a topic called trigonometric functions. And I'm going to write down the question and proceed to the working so that you can be able to get the answer that the examiner was expecting the student to get during that examination. And the question is 3 sine into brackets 2x minus 15 cos degrees, and this must be equal to cos 2x minus 15. Very good. So 3, the sine of this angle must be equal to the cosine of this angle. So, and of course, if I look at this question, I have realized that the angles on either side of the equal sign are the same, or they are equal to each other. But 3 times the sine of this value must be equal to the cosine of the same value. And of course, we can be able to use a particular trigonometric identity so that you can be able to arrive at the final answer. There are several trigonometric identities used in mathematics. For example, we have cos theta squared plus sine theta squared. The answer must be equal to 1. So the cos of theta squared plus the sine of theta and again squared must give us 1. Well, literally, someone can be able to say tan theta should be equal to sine theta over cos theta. That can be another trigonometric identity that you can be able to use to arrive at an answer to a particular question given in an examination, as far as the working out of these questions in this topic is concerned. So you can either be able to employ the use of this or employ the use of this. Okay. But of course, sometimes you always say that the sine of an angle, and of course divided by the cosine of an angle, should be able to give us this as our answer in terms of taking that theta, getting its tan. When you get its tan, the answer must be equal to the sine of that angle divided by the cosine of that angle. And because we may not actually be able to use this first concept, because none of these functions is squared, we can be able to decide and be able to use this. And of course, we have so many other functions or identities. You must have actually heard of this, which says A over sine A should be equal to B over sine B, which should be equal to C over sine C. That must be equal to 2i. This is mostly used when a particular circle and a certain triangle have a particular relationship. In this case, you'll find that you will actually find a circle drawn inside a triangle. That is what you call inscribing. You have what you call circumscribing, where a circle is drawn around a triangle and the circumference of the circle touches the vertices of that triangle. So let's just take ourselves back to the question. So we shall be able to divide both sides by cos 2x minus 15. Why? I want to employ this tan theta should be sine theta over cos theta. So I want to ensure that it is sine theta over cos theta. So I divide this also over this purpose of getting the answer. So we have cos 2x minus 15. So then later on, I know this and this will disappear for me to end up having 1. Okay. And now we can be able to have 3 sine 2x minus 15 as an angle divided by cos 2x minus 15 as the same angle. The answer must be equal to 1. And I know very well that in such a case, sine 2x minus 15 over cos 2x minus 15 turns out to be tan 2x minus 15. Why? Sine theta over cos theta is equals to tan theta. So sine of this angle over cos of this angle translates into tan of the same angle. So sine 2x minus 15 over cos 2x minus 15 translates into tan 2x minus 15. So this must be equal to 1. Okay, the next we can be able to now get the value of x by doing what? By dividing all three as a coefficient. You see, so that means you want to actually make the coefficient of tangent to be 1. So we shall divide all three by 3 so that this and this will disappear. So we shall have tan 2x minus 15 as an angle, which will be equal to a third. In any case, you want to get the value of a particular angle, which is in brackets, for example, or a particular value. And there's a coefficient that gets seen just beside this trigonometric function or identity. Divide all through by that coefficient. Make that trigonometric unit or coefficient to have a coefficient of what? Of 1. So then that means we have tan 2x minus 15 is equals to a third. Next, we shall get the tan inverse. So that identity is eliminated. So we shall have now 2x minus 15 should be equal to the tan inverse of the third. So shift and then tan of 1 over 3. That is 18.439. So 18.435. So 18.435 degrees. So that can be our first possible angle that we can be able to actually rely on in as far as this working is concerned. So we can just say shift and then tan of 1 over 3. Very good. I hope that is the answer. So shift and then tan 1 over 3. You need to do the resetting of a calculator to ensure that the answer is correct. Okay, it's fine. So then we shall be able to get any other possible angle that can be able to fit into this in terms of using what we call a unit circle. You must have heard of this, so it's not something new to you. So we will actually be able to know this is 0, this is 90, okay, this is 180, this is 270, and of course you can have 360 here. So of course the tan of this is positive, so you need to know which angles can give us a tangent which is positive. We know here both the sine, the cosine, and the tan are all positive. But here we only have the sine being positive. Here we have the tan, and we have what we call the cosine. So we can come here, and we should say 180 plus this for us to get another possible angle. So 180 plus the answer. So we have 198.435. 198.435. Okay. Then we can add again plus 18.435. We have 216. Okay, 216.869. Okay, 869. Okay, so 8695. So 869 or 870. 870. Okay, we can also add 18.435. We're getting all possible angles. So we can have 235.305. As long as you know that any value you get must either lie in this category or lie in this category, and not here and not here. Correct. So that one plus 18.435 to 53. We have 253.740. Okay. So plus 18.435. That is beyond, so you can be able to go beyond that. So any other possible values, you can come back to this end. So you can be able to say 90 minus 18.435. So you have 71.756. Okay, 71.756. Also lies here. Then you can be able to say minus 18.435. You have 3.13. And minus 18.435 gives us 34.695. Okay, 18.435, then say times 2, can have 36.87. So those are just the possible angles you can be able to get in terms of this working. So let's see which one gives us a tan when you get their tan inverses. Okay, let's begin. So shift tan of 18.435. So tan of 18.435. So this is okay. Then tan of, we want to see when you pick tan of that value, does it give us that a tan so that you can be able to work with it? So tan of okay, 198.435. It is also fine. Okay, tan of 216.870. That is wrong. Then tan of 235.305. It is wrong. So there shall have tan of 253.740. So we have tan of 71.756. It is wrong. So tan of 53.13. It is wrong. So tan of 34.695 is wrong. Tan of 36.87 is also wrong. Let's see. 6.87 plus 18.435. Okay, the tan of the answer is also still wrong. So we have a possibility of getting two very important values in our case here, and of course we can be able to now even just come here and be able to say 90 plus 18.435. 108. Okay, let's see. Tan of this answer. It does not give us the answer. Then you can say 90 plus 18.435 plus 18.435. So the tan of the answer, it does not. So 18.435 times 3 plus 90. So the tan of the answer does not. So we have those two values. So we can be able to come here and say 2x minus 15 should be equal to 18.435. So we shall do this. Shall actually take 15 on this side. So we shall have 2x is equals to 18.435. Okay, plus 15. We shall divide both through by 2 as to get the exact value of x. So 18.435 plus 15, then divided by 2. So that answer is 138.26 degrees. And now it will be 2x minus 15. Okay. Let's see. Write down the right thing here. Let me see. 18.435 plus 15, then divided by 2 is 16.71. That will come to 72. So 2x minus 15 is equals to 198.435. So take this on the other side. So we shall have 2x is equal to 198.435 divided by 2. That must be plus 15. So we need to get the other value of x. Okay. So we shall have 198.435 plus 15 divided by 2. That gives us 106.72. Thank you so much.